Okay, everybody, let's start today's lecture. Are there any questions from yesterday's lecture or another material?
Sir, I have a simple question if you have free time.
Okay.
Yesterday in the class you said something about like we cannot use the stuff that you haven't taught us in the while solving your homework.
Yes.
And since you haven't taught us about the recursive functions, and
No.
when
You
we are
learn about recursive functions in C. You could use recursive functions.
so we can use because otherwise I cannot solve the questions.
Well, I mean, the using recursive. I mean, this is one thing that I need to say. Okay, I will be clear on this. There are many solutions available on the web. Okay, for this type of game, and those type of solutions, they use this minimax algorithm, and it's a very well-known algorithm. It's a very simple algorithm. If when I say you, I don't mean you. Okay, if you get some kind of a solution off the web that uses these kind of recursive solutions, you will definitely get minus 100 from this homework. I don't want your system to be super smart. Okay, I just if you are making a choice between two moves, just try to make it a little bit smarter. Okay, don't try to make it smart. When people say I am going to use a recursive algorithm, immediately it comes to my mind that somebody has found a solution that is based on minimax algorithm, which is a recursive algorithm. And quite frankly, it is not easy to think of that solution yourself. Okay, and that's going to be bring some bells on my mind, and that's not going to be good. That's why if you figured out something yourself, yeah, you could. But if you got the idea from somewhere else, that's a dangerous choice. That's what I'm saying. Okay.
Yeah, I understand. I'm just using the recursion for finding the winner. Not, otherwise, I'm not using any recursion algorithms.
And it is valid for you too. Recursion is not written that way, by the way. Okay. Um, if you figured out that solution yourself, yeah, that's fine. But if you find some kind of a similarity with somebody else, okay, with somebody else, then that's going to be a problem. Okay, that's what I'm saying. You learned about recursion in C. You know about recursion, but you don't know about minimax algorithm. You don't know about A star search. You don't know anything about that kind of artificial intelligence stuff. And we are not going to grade your homework about regarding its smartness. I mean, we are not going to say that this is dumb. Okay, minus 10 points. What we are going to check is if the moves are valid, and if the game is played according to the rules. Okay. Okay. Are there any questions?
So the AI part of the algorithm shouldn't have to be so smart, like real good. It can just guess. It can make an educated guess, not a like random guess.
No, even a random move is okay.
Okay, thank you, sir.
Okay. Because that would be too much for you at this phase. I mean, as a second year student of computer engineering program, that would be too much to expect from you to come up with a smart algorithm. But if you like to play with it, because that's the beginning of the semester, you may try some stuff like, I mean, if I have 5 choices, which one would I choose? This one or that one or that one? A completely unrelated move, or maybe a move towards the center, maybe a move towards the other pieces that I played before. Something like that, okay? Okay, so any other questions? Any other questions? No? Okay, good. So let's continue with the overloading, parameters and overloading. We said that with the functions, of course, you have your parameters, you have your arguments. We talked about it, and we talked about call by value, call by reference, and simulated call by reference last time. And with the call by reference, we said that the advantage is there is no copying. So sometimes we prefer using it this way with a constant modifier at the beginning of the parameters. So we know that it's call by reference. So it is not the value is copied, but I don't want the parameter to be changed. So I use a constant at the beginning, and we will keep saying this a lot. But we are not going to use it with the fundamental types. We are going to use it with classes like string and that kind of stuff, and we will see. And we said that with the overloading, okay, with the overloading, this definition is important. Signature definition of signature is different for C and C++. One of the biggest differences in terms of using functions. When you define these three functions in C, it's a syntax error. The C compiler says that I cannot compile this. This doesn't make any sense because these functions all name the same thing. But in C++, these are okay because C++ signature says that all these three functions, they have the same name, but their signatures are different. Why? Because their parameters. I think my connection dropped out and I'm back right now, right? Yeah, you hear me, right? Okay. So this is different for C++. They can all have the same name, f, and as long as their parameters are different, you are fine. And in fact, actually, I wrote a small program just a few minutes ago. Okay, this is my test.cpp. Sorry, test.cpp. Okay, it's a very stupid small program. All I have is function f doesn't take any parameters. Okay, it just returns 1. Function f takes an integer. Function f takes a double. Function f takes an integer and double, and function f takes a double and integer. Okay, so I have 1, 2, 3, 4, 5 function f's, and I am saying that since the signatures of these functions are different, they should be compilable. So if I compile it with G++, I am going to produce the code, assembly code, so that we can see how the compiler deals with this kind of stuff. Let's first compile it with GCC. Okay, well, GCC compiled it because I didn't set the, okay, minus, let's do this, okay. G++ minus S, it produced this test.s stuff. Let me show you the content of it. vi test.s. Okay, so let's go to the end. It is a small assembly because I didn't have any includes everything. Okay, so this is, where is the beginning of main? Let's find the beginning of main. Yeah, I guess this is the beginning of main function. Okay, function main. There is nothing interesting in it. Let's look at the definitions of the other functions. See, this is the beginning of the function f that takes a double and integer. So the assembly function that corresponds to my function that takes a double and integer became fdi, right? And the other assembly function that takes an integer and double became fid, and the one that takes a double is became fd, okay, and the function that takes an integer became fi, and the function that takes nothing became fv. I guess v means That means void, right? FV. Okay, so it looks like the compiler is using some kind of a technique to rename all of these overloaded functions. And for the assembly there is no overloading. Each function has its own name. Okay. There is a question. Sorry, you keep reminding how. Okay, there is. I am very concerned about it. You don't have to be, Ryan, concerned about it. We know what random similarity by randomness. We know the difference between similarity by randomness and similarity by making a copy. Okay, you don't have to be. I mean, I know that many people would use this. Yeah, I know this, right? We have been doing this for the last 10 years. We kind of have experience. Okay. I mean, I wouldn't want to talk about this cheating stuff too much. Okay. But unfortunately, it happens. I know that there are people, for some reason, even a simple homework like this, instead of doing it themselves, they try to find some source code from some other place. This is not a difficult homework, okay? And I repeatedly told you that I am not going to grade this in terms of smartness. So don't try to find some solution from some other place, okay? You should be able to do this homework without looking at some other code, okay? That's all I am saying, okay? Don't try that kind of stuff. Don't try that kind of stuff, okay? So similarity by coincidence, we know that kind of code, okay? We know that kind of code. Yeah, so as long as you are doing it yourself, you should be fine. Some people kept asking us, how come I got a minus 100? I even don't know that guy. When I ask him, how is this code possible? How is it that possible that you are typing exactly the same wrong code? And he said that I got this code from somebody else, and it was etc. and etc. Him. So I am trying to prevent these kind of situations when we start grading stuff. So I like to keep the things a little bit tight at the beginning of the semester. So if you are doing everything yourself, you should be fine. Okay, yeah, so get concerned about your homework, not the similarities. That's our concern. Okay. Again, for the overloading, all the compiler does is it just renames all the functions with unique names, like the C compiler. Okay, so at the end, everything is converted to different names. We kept saying that usually I get this question from people, but nobody had asked me this time. In the signature, we don't have the return type. Okay, all we have is the name of the function and the parameters and their order and the type of the parameters. Okay, so why didn't they include this return type as in the signature? I mean, can't I say the same thing? Can't I say the same thing? Okay, a function f that takes a double and returns a string. The compiler says that no, this cannot happen. Why? Because these two have the same signature, right? These two have the same signature. Why? Because their names are the same, their parameters are the same. Well, you may say that their return types are different, but return types are not within the signature, are not in the signature. So what is the reason for that? The reason is this. When I make a function call, when I say 1 the compiler knows that this takes an integer. When I make a function call 1.0, the compiler knows that the function is taking a double. Okay, I know that. Okay, but how am I gonna make a difference between these two? Okay, when I say 1.f 1.0, should I call this one or that one? You might say that let's look at the other side. Let's look at the type of the left hand side, the R value, left L value. What is the type of the L value? But in C or C++, I don't have to use the returned value of a function. Okay, I may call the function like this without using the return type. Okay, so that's why they did not include the return type in the signature. Okay, good. So with the overloading, we did these examples, and average example I gave you, and overloading resolution. Again, if I have a function f that takes a double and a function f that takes a string, okay, I have two functions, and in my main function I call it with a integer. So the compiler is going to look for an exact match. This is an integer. Are there any function f's that takes an integer? No. So it doesn't give up. It says that, okay, can I make a compatible match by promoting this integer to a double or string? Well, I cannot convert a integer to a string, but I may convert an integer to a double. So by doing this with the promotion integer to the double, I will make this call. Okay, so overloading resolution might be handled this way. Okay, if since one can be converted to a double without losing any data, this is the preferred way. But if there are other ways like the demotion, by converting a double to an integer, if I am losing data, this might be used to in case where the promotion is not possible. Okay, so this is the second alternative to resolve an overloading situation if you don't have an exact match. Of course, we talked about this. We said that we should be careful about this. Declaring these kind of functions is no problem as long as you don't make these kind of calls. By the way, it is possible to do this. I like to call, you may do this calling. I like to call integer double version of, that means this one, integer double version of a function with these parameters 4.1 and 5.2. Okay, so there is it's a new syntax in C++. You are specifically saying that I am calling this function. Which function is this? It is this function. So you don't let the compiler resolve your overloading. Okay, you give the exact function, which function to call, to the compiler. Compiler doesn't do this overloading resolution. Okay, good. Automatic type conversion is something that we do all the time, especially with the integers and doubles. So the book says that if you are smart enough to design your function like this, miles per gallon, okay, this is the miles and this is the gallon. If you take your miles and gallons in doubles, then if you do this division, in that case, I may call it with an integer, two integers, two doubles, one integer, one double, and it's going to be automatically type converted, and you are going to use this function with integers and doubles and floats and etc. Yeah, Atakan, that's what we said last time, right? What did we say last time? Which one this one is going to call? The compiler doesn't know. So that's the compiler error. It could be either this one or that one or that one. Okay? So that's a compiler error if I don't use the angled brackets. This was the last slide that we discussed last time. Okay, good. So another new addition in C++ is the default arguments. Default argument says that, okay, sometimes if the number of parameters to a function is too many, 5, 4, 6, 7, 8, and most of the time the arguments doesn't change much, you may want to omit some of the arguments when I call this function. Okay, let's look at this show volume function. If you declare your function header like this, a show volume taking 3 parameters, okay, and returning a void, okay, you may call this function with 3 parameters. 2 is copied length, called by value, 4 is copied to width, and 6 is copied to height. Yeah, I know that. Okay, but if you like to call this function with 2 parameters, 3 will be copied to length, 5 will be copied to width, and the third one is missing. Third one is copied a value of 1 here. And if you call it with a single parameter like 7, so the 7 will be copied to length, width and height will take the values of 1. Okay, so let's see the code actually. Okay, show volume, this is the declaration. It takes 3 parameters, but the last 2 are defaulted. If you are defaulting arguments, you should always start from the right. If you're gonna default only one, only this one should be defaulted. If you're gonna default 2, these 2. If you're gonna default 3, then you may default all of them. Okay, you may default all of them. Just a minute, I'm trying to do, just a minute. Okay, so let's look at the without looking at the function okay, let's look at the function implementation. Function implementation is here, line 15. As you see, I don't repeat the default arguments. Okay, the default arguments are only given once. Okay, not every time you declare and you implement your function. Okay, in the declaration I have the default, in the implementation I don't have the default. Show volume is a very simple function, and all it does is volume of a box with length and width and height is length times width times height. Okay, so that's the simple function. So if you run this program, okay, show volume 462, I will call this function. 4 times 6 times 2 is 48, right? And it will print 48 at the beginning. Okay, 4 times 6 times 1 is 24. It will print 24. 4 times 1 times 1 is 4. So 48, 24, and 1 will be the output. Okay, it's a very simple mechanism, but it's very useful. We use this a lot. It looks like the show volume is overloaded 3 times. But no, we did not overload it. We just use the default arguments. Okay, we just use the default arguments, and if you call the show volume with less than 3 parameters, these default arguments are going to be replaced with the are copied to the parameters. Okay. Any questions about the default arguments? And if you put another one, if you put another default argument in there, then in that case I can call this show volume. Okay, so it looks like I have 4 different overloads of the same function. Okay, if there are no questions, then I will continue in that case. Okay. At the end of this chapter, the book talks about debugging, testing, and debugging your functions. Okay, how do you debug your functions? Well, I mean, you have been writing programs for the last 8-10 months, I don't know, and I am sure when you write a program long enough, 10, 15 lines, 20 lines of code, there will be errors. I mean, other than the compiler error, there will be logical errors. Sometimes you forget to increment some value, or you forget to write the else statement of a if statement, etc. So how do you test and debug your functions, your programs? Usually what people do is you put lots of cout statements. Okay, for example, if you have a function, a void function g, it takes one integer and a string s. I don't know what it does. It does something. Okay, maybe let's return a double. It does something, and at the end it returns a double. Return d. Usually people do this. If things are not working the way they want, they do this kind of stuff. They say that, okay, at the beginning, excuse me, I need to take this. Efendim hocam. Teşekkürler hocam. Siz nasılsınız? Evet. Evet. Evet. Evet. Evet. Evet. Evet. Evet. Hocam o yani SAP'yi bilen bir şey, o kendisine basit gibi gelebilir ama o karışıktır yani onun detaylarına. Ama işte yani böyle iş dünyasıyla alakalı geldiği zaman enterprise yazılımları deniyorlar bunlara. Birisine indirip onların yaptığı işi kafasına sığdırıp anlayıp ondan sonra kodlaması lazım. Yani o kadar beklediği kadar basit bir şey olmayabilir o. Yani o çözümü öğrenciyle öğrenciyle o kadar önemli bir işi öğrenciye falan yazılımı şey düşünmemesi lazım. Yapalım bitsin çeksin gitsin ellerine notu. Hayır o kesin problemi çıkarıp birisinin ona sürekli bakması lazım. En azından 1 yıl 2 yıl güncellemesi falan lazım. Bence profesyonel bir çözüm aslında. Evet. Evet. Profesyonel çözüm bulmak konusunda. Vallahi bilmiyorum ki bu logoyu falan filan tanımıyor muyuz biz? Logo falan ya logosu. Hocam öyleyse Yakup Hoca'yla konuşalım. Bu BT için belki bir proje olabilir. Yani burada birilerinin çalıştırması lazım. Birilerinin çalıştırması lazım bu konuda profesyonel yazılım geliştirebilecek ve destek verebilecek. Yakup Hoca'yla bir konuşalım. Belki BT'de bir çözüm geliştirebilir. Evet. Oradan konuşuruz. Daha yanlar proje konuşursa konuşursak. Belki de başka bir şeydir. Evet. Yok belki detay vermişlerdir falan yani. Olur hocam. Biz telefonumuzu verin biz görüşürüz kendileriyle. Şükür hocam dersteyim ders yapıyorum. Şükür hocam bir yaramazlık yok. Evet. Evet. Evet. Hocam yani boş durmaktan iyiydi. Denedik biz en azından. Yani prestijli üniversite. Evet yani çok kolay olmayacak. Tabii biz de arıyoruz ama bir deneyelim bakalım belki gelir. Oldu hocam. Görüşmek üzere. İyi çalışmalar. I am sorry, that was the director of the university. I had to answer that one. Usually we do this. Usually we do cout. I print out the integer, then I print out the string. Okay, so that I would know what I am getting from this, from the outside. Okay, and before I return that result D, I print out that D, cout D, so that I would know what I am sending out from this function. And when I run this program, if everything I am getting is right, and if everything I am returning is right, then I know that there is no problem with this function G. Okay, you do this kind of debugging techniques, right? So what is the problem with this kind of solution? What is the problem with this kind of solution? Debugging technique. Anybody? Okay, if there are no people answering it, then I will pick somebody random. Okay, this time let's pick someone in the middle. Enes Sefa Çetin. Enes Sefa. Okay. Tell me, what do you see wrong with this solution?
When we use cout as to debug,
Yes.
it uses CPU and memory. That's the thing I see wrong, and that can cause another problems in recursive functions or another functions. That's the problem I see.
So you are saying that if we use these couts and cins, they would confuse the user. Why? Because I am printing out. Oh, you are saying that
No,
since
not the user, since they consume memory and CPUs.
Oh, you
Like,
are saying that this is an efficiency
these-
problem.
Yeah.
Oh, okay. So I am spending lots of memory and CPU time just because I need to do some debugging. Yeah, that's correct. So what would you do? And the other thing is, related thing is, I mean, the user doesn't want to see these statements on these printed out statements on the screen, right? The user is not interested in my debugging outputs. So what am I gonna do to do that? So I do my debugging. After I am done, okay, after I am done, then I just erase this one and erase that one, right? And compile it. Okay, after I debug my program. But what happens if I need to debug it again? Do I put them back in? So that's going to be a problem. So here is what I do. I would say that, okay, let's use a preprocessor directive define stuff. Okay, like when if I would say this, okay, if def a flag, a debug flag, okay, then and if, and do the same thing here. If def, okay, debug, and if here. So this part of the code and this part of the code will be compiled only if I compile my program with G++ minus D debug, right? If I compile my program with minus D debug, on my screen I will see these debug printouts. If I don't include that one, okay, I won't see it, and I don't have to do the erasing and retyping again. Somebody said that, why don't we use C error? Well, I mean, instead of using C out to C error, the user is going to see the C error too. And as our friend said, printing out to C error is again is going to make me lose some CPU time and memory. Okay, I don't wanna deal with that when the code is delivered to the customer. When the customer has the code, the customer should not have any debugging printouts, any debugging related stuff. So this is a clearer, more efficient way of doing this debugging stuff. So if I don't define the debug, this part of the code will not be compiled and this part of the code will not be compiled. So my code will be as efficient as no printout statements. Okay. Okay, so that's good. Lots of printout statements, lots of cout statements. That's one thing to debug your programs. The other one is compiler debugger. I think your TA, Ilhan, I guess, showed you how to use the debugger, your compiler debugger, development environment debugger, using NetBeans or your Visual Studio or Eclipse. Okay, so that debugger usually helps a lot. We are not going to teach you that, but you are supposed to learn it because that will make your job a lot easier. Nowadays the debuggers are very, very sophisticated. They will let you see the contents of the parameters and the variables and the array members and even the registers. You may check the values of the registers if you like. Okay. Another solution is another technique that we use is the assert macro. Okay, and somebody was suggesting let's use assert macro. Let's look at what assert macro is. First of all, assert is a macro. What does that mean? Macro is defined by the preprocessor. Okay, and it's a preprocessor directive. Actually, it is not part of the it's not part of the it's not a function. Assert is not a function. It's a preprocessor directive, and let's see what it does. Okay, it is used like this. You make it like a function call. You make a call assert, and you put a assert condition in there. Okay, assert condition in there. It's like this. Let's say I have a function that should return an integer, and it will take an integer I, and as a precondition I said that I should be greater than or equal to 0. Okay, so I am asking the user of this function to send me an integer that is greater than or equal to 0. If the integer I is less than 0, then it's going to be a problem for my function f. If it will not run correctly. Okay, so you might think that it is the responsibility of the user to provide a positive or 0 integer to it. But what happens if the user is not careful? So at the beginning, I could have done this. I could say assert I is greater than or equal to 0, and I just continue. Okay, what does this do? When somebody calls my function f, it checks that I has the correct value by doing this assert macro. Okay, assert macro. If I is less than 0, then it will terminate my program. And it will say that I found an assertion at line, let's say this is line 351, and the file is just file.cpp. During the runtime, I will get this message. The message will say, I found an assertion in file cpp, okay, in file cpp at line 351. So during the runtime, I will get this error message. My program will be terminated, and as a developer, I will know that there is a problem with my program. Of course, as a developer, this is a very good, useful information for me. But if I am the end user, if I am the regular customer of this software, of course, you don't want to see these kind of messages on your screen, right? Okay, this is only for debugging. You know that there are problems with your code, and you are trying to find out if f is called correctly, then you use this assert in there. To be able to use this assert macro, okay, you include this header file, cassert, okay, and that assert macro becomes available and you use it. Again, this is for yourself as a developer. As an end user, for example, let's say I am using this notepad. Okay, I run the notepad. Okay, I get this nice interface, and all of a sudden I get a new screen. The screen says that I found an assertion at line 500 in this file, and I am terminating this program. Would I like it? No, of course not. I would not like this. Okay, so the end user should not see the assertion results. So why are we using asserts then? Asserts are good for us as programmers to find the errors while we are testing our programs. So before I send my final software to the end user, I should remove these asserts, okay, by erasing them, or maybe I should not erase them, because there is a very good way of doing things, like you just compile your program with the no debug. Okay, if you define this flag, no debug, all the asserts will be gone. No asserts will be compiled. And your end user will not see any assertion statements. Of course, I am assuming here that your program is free of errors. So this is how you turn your asserts on and off. Since there's a preprocessor definition flag, okay, it makes sense to make this assert as a macro, as a preprocessor directive, because it's not part of the language. Before the compiler comes in the picture, these assertions are either accepted or not accepted, depending on this debug flag, no debug flag, okay? Okay, good. There is one thing that you need to be careful about, okay? Here is a simple employment of assert. This one says that compute coin will take 3 integers, coin value, number, and amount left, okay? Integer reference and reference. The precondition is coin value should be between 0 and 100. Amount left should be between 0 and 100, etc. So how do I know that the user of this function called me right? So I put an assertion statement at the beginning of the function. If this condition is not satisfied, then my program will be terminated. And I will get an assertion error. Okay? I know that this assertion is only valid, okay, will work, if no debug flag is not defined. So you should not do anything that can change the rest of the program execution in an assert statement. Here, okay, this is a very, very bad code. Let me do this. Maybe, okay, you might say that the first thing I do in this program is maybe the increment value of I. You might think that why don't I do this? Okay. Instead of doing that, okay, I am just checking the value of I. It should be greater than 0 or equal to 0, and I'm incrementing at the same time. But this is a very bad code. Can somebody tell me why this is a bad code, very bad code? Any answers? This is a very bad code. I don't like this code. You might say that what is wrong, because you are going to increment the value of I anyway. So you are checking the value and incrementing it. Well, Mohammed Bedir, yeah, that's true. It is hard to follow, yeah, but other than that, it is not readability problem only. It's a logical error. I will be in a big trouble when I deliver this code to customer. Well, this post increment is right, because I want to increment the value of I later. I mean, I like to check the initial value of I first, then I like to increment it later. Okay, Yunus Emre says that because if you don't use debug, function will work differently. Yeah, exactly. If I compile this code using G++, just f.cpp, the code that is produced will do different stuff than G++ minus the no debug f.cpp. Okay, when I define this no debug, what did I say? This line will go away, right? If I compile it that way. So in that case, I will not be incremented. But if I compile it this way, I will be incremented when I call the function I. So I should be careful about these kind of situations in C or C++. Okay, so what Yunus Emre is saying is correct. What Mohammed Bedir is saying is correct too, but I mean, yeah, well, this is not a good code readable. This is not a readable code, but it's not about readability in this case. It is more than that. I mean, it is a logical error. Okay, so While you are debugging your program, everything works fine. If you send your customer your code with the minus no debug option, and then your code will behave differently. By the way, G++ has optimization flags. G++ minus O3. It optimizes your code so that your code will run faster. When you define this optimization flag, it automatically defines no debug. Okay, it automatically defines no debug. So I would suggest you use, instead of define if def debug, then maybe you should use if not defined no debug. Okay. So did they teach you how to write macros using the preparation directives? Did they teach you how to write macros? Well, I mean, I don't know if they did it, but it's a good exercise. Just exercise. Okay, write macro, assert yourself. Okay, write the macro, assert yourself. It is not that difficult. You just execute a statement. If it is true, then you are fine. If it is not true, then you should terminate your program and print out the line number. Okay, good. Any questions so far? Okay, no questions. Then I will continue from this point. Assert on off, and I think I am out of time for the first part of the lecture. Let's take 10 minutes of break. 11:22. Let's be here at 32. Okay, 10 minutes of break. İyiymiş, bu önemli bir şey mi? İnkılap tarihi. Teşekkürler. Okay, people, let's continue from where we left. Again, we are talking about testing and debugging your programs. Usually, when you start a big programming software project, you design your whole software and you design each of your functions. Okay, you would say that I am going to have many functions, such as a function f1 that will take a double and an integer, and it will do precondition and postcondition, and another function g2 that will return a double and it will take parameters and its comments, etc. Let's say you have hundreds of such functions, okay? Hundreds of such functions. And you have a team of software developers. Doing the development at the same time, let's say 10 people. So each one is working on their own functions, okay? Each one is developing their own functions after you did the designing. So the coding, while the coding is being implemented, coding is being executed, okay? Each developer should have his or her, okay, I think I am back. Okay, each developer should have his or her own, okay, functions, and before everybody completed their coding, they have some kind of a testing, okay, their functions. How are they gonna do that? And this Stubs and Drivers are talking about it. First of all, let's say I have a function. As a team member, they told me that, okay, my task is to write this unit price function. They told me that it's going to take a diameter and a price, and it will return the price per square inch of a pizza. My task is this. So I am done. I write my function, but before I hand in my function to the team leader, I like to test it. How am I going to test it? I will write a driver function, my main, okay? My main is not a useful function for the end user, but it's going to be useful for me as a developer. I have implemented my unit price. It takes two parameters. I have a nice constant double, local. I calculate the radius and the area, and I divide the price over area and return it. I mean, the contents of this function is not that important. But using this main function, I am testing my program over and over again. Nobody other than me is going to use this main function. They are interested in this unit price function, but I need to test this unit price before I send it out to the team leader, saying that, okay, my function is ready here. Please use this one. I tested it. Okay, I have tested it. This is what we call drivers. Okay, driver. We write driver code to test your functions. Okay, to test your functions. So not all the code that you write will go to the end user, will go to the paying customer. Okay, almost half the code that you write will be for testing and debugging. Okay, only half of the code, the compiled code, will go to the final customer. That's the rule of the planned or proper way of developing software. Okay, not all the code will be useful for the end user. For example, this main function is good only for me. This main function, there is a do-while loop. It asks the diameter and the price from the user, and the user enters it, and I call my function and I ask test again. So it is good for testing. Okay, so that's one way of looking at development with a team. The other thing is this. Okay, remember this picture again. As a developer, my task was to develop this function f1, and I tested it and everything fine. But how about the team leader? Okay, the team leader says that, okay, in a month, everybody, all of these 10 people, they are going to implement their functions nicely and they will return to me. But what should I do before they return their functions? I mean, should I sit and wait? Or maybe I could do something. This is what I do. I will just do this. Return 1 and return 2.0. So this is a compilable function and this is a compilable function too. So I write these kind of dummy functions whose interfaces are exactly promised. It takes a double and integer and returns an integer and it returns an integer. It doesn't do anything useful. It is just compilable code. So as a team leader, I can compile my software with this kind of code. I know that it will not work correctly, but at least I know that the whole thing is compilable. Okay, the whole thing is compilable, and if it doesn't compile, then that means that I made a mistake. Okay, there is a design problem. There is a design problem. So this kind of coding is called stub coding. Okay, this is a driver program, and stub coding is this. I did not implement anything. I just return a double, that's it. It still works, it returns a number, it is compilable. It will not return the correct results. Don't expect the correct results out of this function, but it will compile the whole system. And the team leader will know that once everything is done, at least he or she knows that everything will be compilable and linkable. Okay, and this is called stubs. Okay, implement your functions in a stupid way to see if everything comes together right and it is compilable. Okay, so fundamental testing rule is okay, ensure the validity of data when you get it from the user or when you get it from the file or anywhere. So for that one, you are supposed to use the assert statements, print out statements, cout statements, like, or using the no debug flags, and test every function with a driver code, or sometimes we do this with unit testing. Unit testing is a testing strategy that tests every small unit of your software, including the functions. Okay, it sends lots of different parameters to your functions, and it tries to understand if everything is working right or not. Okay, so and there are very automated ways of doing this unit testing, and it is done extensively. As I said before, if you have in your code base, if you have 10,000 lines of useful code, you're going to have more than 10,000 lines of unit test code and testing code. Okay, that testing code, unit testing code, is for you, for the developer. Okay, for the development team, not for the end user. Okay, if all of my useful code passes these 10,000 lines of testing, then I can kind of say that, okay, I tested this enough, I can send it to the customer. Okay, so that's the end of this chapter number 4. And with this chapter, we looked at this stuff. Okay, parameters and overloading, call by value, call by reference, and we visited back our simulated call by reference again. Okay, again, repeat this. Simulated call by reference is a form of call by value. With the simulated call by reference, what you are copying is the address of a variable. Okay, since you are copying the address of a variable, it looks like you are going to change the value of that variable, but you are doing this some pointer stuff. Okay, so in C++ though, there is a direct way of doing the call by reference. Okay, it's a new way. Then we talked about overloading and we talked about default arguments, and those are the new things in this chapter: call by reference, overloading, and default arguments. And I think some of this stuff, say maybe the assert macro is new stuff for you. Any questions? Any questions? I guess there are no questions. In that case, I will start the new chapter. Okay, our new chapter is about arrays. Let me try to, where are my arrays? Oh, okay, good. We'll talk about arrays, but I don't want to get these. Okay, good. Chapter number 5, arrays. And I'm going to be quick again. I think there is only a few things that is different from C. I will make a few discussions about how we look at the arrays from the object-oriented point of view. Okay. Other than that, I will not introduce many new things. Maybe it's going to be a good repetition for you to understand it. So, arrays are no different than regular types for me. Okay. When you say I have an integer I, okay, its initial value is 7. So what does the compiler do? Compiler says that, okay, this is your memory. There is a special place named I, and I'm going to put the 7 in there. Then maybe, well, how about this? If I say I am going to have an array, its name is array, it has 10 values in it. Okay, its initial values will be 1, 7, 3, etc. I filled it in. So the compiler says that, okay, I'm going to do this. Array is here, ARR. The initial values will be 1, 7, 3, ... Let's say the last value would be, let's say 10. Let me put a 10 in here. Okay, good. Okay, good. So it's like a variable declaration actually. I is an integer of type integer. Its initial value is 7. ARR is of type integer array, and its initial values are done that way. Not much different. What kind of things can I do with an integer? Of course, with an integer, I can do addition, right? I can do addition. I plus 7. That's possible. I minus 2. That's possible. What else I can do with an integer? Of course, I can do stuff like assignment, right? Let's say integer k assigned I, etc. So these are the things that I can do with an integer. What kind of things can I do with an array? Well, I can do indexing with an array. ARR 5. I can do indexing, an operation. Can I do indexing with an integer? Is this possible? No. This is not good. This one with a red is not good because the compiler will not let you do that. It will say that the operator index is not defined on an integer, but operator index is defined on an array. I know that. Okay. What else? Can I do this? Question: ARR plus 2 and ARR minus 2. Does this work? Okay, let me mark these green. Green means yes. Red means no. Okay, this is possible. And it says no. Any other guesses? The answer is, of course, the answer is not no. The answer is not capital letter no. Yes, it is actually a pointer arithmetic, of course. The answer is of course, yeah. Answer is not yes. Answer is of course. Osman Talha, you have the best answer. Okay. Arrays are same as pointers. It would compile, yes. ARR plus 2 means that I am referring to not this one, but this one. Okay. This is okay. This is okay. Okay. And this is okay too. Well, this doesn't mean much because it would point to somewhere in the memory that doesn't belong to me, but it is possible it would compile. So it says at the beginning of the array, just 2 integers before me. It is just referring to that kind of. So these are pointer arithmetic stuff. It works. It works, right? These are all okay, like the plus and. Okay. How about this? Is this okay with an integer? And is this okay with an array? And I know that this works, and also I know that this one works, ARR plus 2, right? So this one works, and this one. Does this work? The reference I?
No, it doesn't work.
No, it doesn't work because it is not defined. What do I mean by the reference I? It doesn't work. Okay. How about this one? Minus I and minus ARR. Minus I is perfectly valid, negative of it, but minus ARR is bad, right? We don't do that. So here I am trying to say is this: arrays are just another type, right? Like integer is a type, arrays are other types. There are certain operations possible on integers, and there are certain operations are possible for arrays. Okay, and if you know what the possible operations are, and if you know what they are, then you should be fine with the arrays. Okay, and the same with the pointer. Pointers are just some other types. Okay, so I talk about this kind of stuff because at the end, with the object-oriented programming languages, starting with the next chapter, we will start writing our own types, okay? Like integers or arrays, like strings, okay? We will write our own types, and we will make some operations possible, available for the end user on our types, okay? And we should be familiar with this kind of thinking. What is possible on this type? What should I make it possible on this type? Okay. By the way, how about this? Cout I know this. How about this? Cout ARR. What does this do? Cout ARR.
It will print the address.
It will print the starting address of this array, right? That's correct. Okay, that's correct. In terms of assignment, how about this one? Integer. Oh, okay. Integer pointer P ARR, and ARR gets the value of I. Okay. This is okay. How about this one? Is this okay? Is this okay?
Yes.
Okay, yes is the correct answer. How about the last one? Is this okay? ARR gets the value of address of I. since I can assign this, ARR is a integer pointer, right? Basically, it's an integer pointer. Whatever I can do with an integer pointer, I can do it with an ARR. So I assign the value of integer ARR to an integer pointer. How about just the opposite? Can I do this? Can I assign the address of I to ARR? The answer is no. The correct answer is of course not. But no is okay. No, why? Because ARR is a constant pointer. You cannot change the value of an array. Okay, it's an integer pointer, but it's a constant integer pointer. We'll talk about this kind of stuff when we come to the pointers. Okay. Okay, so let's look at this.
Sir,
Yes.
I have a question. Last slide. If we are on the first elements of array, r minus 2, what will happen?
I tried to explain that a little bit actually. If you do such a thing, C out the reference ARR minus 2, this will compile, and if you are lucky or unlucky, this will run, it will print some junk on your screen. If you are not lucky, this will say segmentation error, this address doesn't belong to you. Okay, because I am trying to print out a position like that in the memory, right here. I don't know who lives in this part. It might not even belong to me. I don't know. It might be dependent. It might depend on the compiler. It might depend on the operating system. I don't know. But this is not a good thing. Don't expect anything good out of such a thing. Okay.
Okay.
Okay. So again, I mean, this is C, right? This is not C++. This is C. With C, everything is possible. And if you trust yourself, if you think what you are doing is right, then do it. The compiler will not object to anything. That's why we say that it's a very powerful tool, but with power, there should come some responsibility, right? With the powerful tools, you can do many things, but you can also do many bad things too if you're not careful. So let's go back to arrays. We are gonna look at the arrays, declaring and referencing arrays, and most of them we already know. We will be very, very quick. Okay. So I like to look at this thing first. Aggregate. Our first aggregate data type. When it says our first aggregate data type, and the book talks about this stuff. Aggregate means grouping. All the data types that we have used so far, integers and doubles and booleans, and they are single just data types, just a single boolean, single double, single integer, etc. But when we start using arrays, it's a grouping of many variables under the same name. When I say integer ARR10, I am saying that I am declaring an array of 10 integers. I group them together. Okay, I group them together. Tell me another way of grouping data together that you have learned from your C class. Arrays are one way of aggregating data. What is the other way of aggregating data in C? Structures, exactly. Okay, it's structures. With the structures there is aggregation, but the way that you aggregate is different. Why? Because with the arrays all the variable types should be the same, 10 integers, 12 doubles, etc. With the structs you may have different data types under the same name, under the same struct. Okay, so the next chapter will be about structs actually, and we are gonna look at it that way. Okay, so declaring arrays is just, we know how to do that. I'm not going to talk much about this. And accessing arrays is using the index of operator. Again, it's an so index operator. How many parameters does this operator take? Index of operator. It takes 2 parameters, right? One this, the other one that, right? That's the index of operator. How would you implement index of operator? Remember we have implemented plus operator, minus operator, postfix and prefix. How would you implement the index of operator? Let's say I have an integer array, ARR 10 and ARR 7. How would you implement this? First, it should return an integer, right? It should return an integer index of, okay. Instead of saying cout ARR 7, I will say cout index of ARR, 7. Okay. So what are the parameters? 2 parameters. What are the parameters? The first parameter is a integer pointer, right? That would be our PTR. And second parameter is the integer index. Okay, it's going to be very simple actually. What am I going to do? Return what? Return okay, Yakup Talha, exactly. Return ARR plus index. Okay, that's the implementation of index of operator. Okay, so index of operator is defined. It's very simple. It just uses some pointer arithmetic and that's it. Okay, and array usage, you already know that. Let's look at this simple example. I have a main function, an integer I, an array of size 5 integers, maximum. I ask the user to give me 5 scores. I enter the first score and max is the 0th one. Then I, in a loop from 1 to 5, I get the scores. If the score I is greater than max, then I just replace it with the max. And at the end, I print out, I would say that, okay, I would say that the highest score is max. The scores and their differences from the highest are this, okay? So I print out the max and I will print out the difference between the max and all the others. So this is a simple output. 5 scores, okay, enter 5 scores, 5, 9 to 10 and 6, and it says that highest is 10, and these are the differences. Very basic stuff. Mehmet Hussein is asking, it should be a size of, okay, some people ask a question, okay, let's go back. Shouldn't I use size of int? No, Mehmet Hussein, because what is the meaning of plus for a pointer? Plus is, okay, get the type of this ARR. If it is an integer, then increment this pointer with the index times size of int. So size of int is already done with this plus operator. Plus operator is smart in this case. It increments or it adds index number of integer sizes to this ARR. Okay. So Mehmet Hussein, okay, Berkan says that can return array address. What do you mean can return array address? Index of doesn't return addresses. index of returns integers. Okay. Maybe Berkan is trying to ask some other unrelated question. If it's unrelated, then use your microphone to ask it, Berkan. Okay, so this simple stupid program, we looked at it already. No problem. I'm going to skip it. And okay. As I said, I will be very, very fast. Newcomers to C, they are confused about this indexing mechanism. This one. I have a double array of size 24, and some people will think that my last element will be 24. No, this is your not last element. Your last element is 23 because array indexing starts from 0. Array indexing starts from 0. Can somebody tell me why they decided that array indexing starts from 0? Why doesn't it start from 1? Like the old good people of Fortran. You know this language, Fortran? (1952) or something. 1954, Fortran. Formula translator. Fortran. In Fortran, arrays, I think, as far as I remember, they started from 1. It's like more logical. But C people say that no, array indexing should start from 0. And it doesn't reach to this 24, it just ends in 23 because if you include 0, there are a total of 24 elements. Can anybody tell me why C designers decided that array indexing should start from 0? I gave you the answer. You gave me the answer actually. Anybody? If nobody is answering it, then it is amazing that whoever I picked, they give me the exactly correct, perfect answer. Okay. Emine Sultan Savran. Emine Sultan, it's your turn. Tell me.
I don't know.
I don't know is not an answer. I already know that answer, I don't know. Tell me why they have chosen 0 as the starting address, Emine. I'm sure you have an answer. You have some kind of a guess.
Maybe first element is the address of array.
Exactly. So explain that a little bit more. I'm going to give you a hint. Just a minute. If this stupid thing works, okay. Here is your hint. You see it?
Yes. Yani.
It is exactly what you said. It is the if indexing started from 1, okay? If my initial element, the beginning element is 1, then I would add 1 to this array, then my starting position would change, right? So it makes sense to start from index number 0 so that my top element, okay, of the array is the 0th one. So otherwise, I mean, if they started doing this indexing from 1, this would have been the solution, right? Index -1. So why do I do this subtraction all the time when I do this indexing? This is too expensive. That's why they made this decision. Okay? So it's not that difficult to guess why they made the decision. Okay, good. So major pitfall, we talked about it, and your last element will never be 24 in this case. And defined constants, this is okay. When you always use a constant to give your array size, never a variable. Don't use any variables in the array declaration. Don't do this. Integer size 10, and somewhere along you do this double ARR size Okay, this is not a valid C statement. Some compilers compile it, but they don't have to compile it because you cannot put a variable in there. Okay, no variables here, no variables. Okay, but if you do that, const. Okay, if you do that, that's fine. But in that case, I wouldn't do this small case. Okay, lowercase stuff. I would do it with the uppercase size so that everybody knows that this is a constant. Okay. Okay, Gökbey, I don't know what you mean because ARR plus and ARR looks alike. Yeah, well, yeah, I mean, the calculation is the same. Calculation should be ARR1, should be ARR plus 1. Otherwise, I have to do some subtraction first. Okay, good. So Ozan asking a question. I don't know why you asked that question, Ozan. Yeah, well, that's of course that should be fine. Why? Yeah, that's okay. But the last element to print is ARR 9 in that case, not 10, because I should be less than 10 all the time. I said, oh, okay. I said no variables when you declare the array. When you are declaring the array, always use constants. Okay? When you're declaring array, always use constants. We are talking about, okay, array declaration here. So we should use const number of students in array index. So I could not understand clearly, and I could not understand what you are asking, Sinan. If you just use your microphone to explain it. This is a constant and I'm using it to declare my array. You cannot have a variable here. That's against the C rules. You cannot have a variable there. That's against the C rules. Okay. Again, the defined constant, the named constant, and that's going to be it. Okay, so let's look at this one. C++ has a new. Okay, this is the first new thing that is added to the arrays with C++. Actually, C++ 11. It's called range-based for loop. Range-based for loop. With the range-based for loop, you can do this. You can do this. Let's say you have an array of size 4. By the way, this is how you initialize the arrays without specifying the array size. So the array size will be 4 here. So you say that integer x ARR with a column. So this x will iterate over the values of this array. First, in the first iteration of the loop, the value of x will be 20, then 30, then 40, then 50. And every time it will be printed out on the screen. So the output of this program is going to be 20, 40, 40, and 20, 30, 40, and 50. Okay, so I can write exactly the same thing for using our old integer I from 0 to I less than 4 plus I and integer x gets the value of ARR I and cout x and at the end, oh, okay, cout end of line. This curly bracket doesn't look okay. This is not curly enough. Okay. Okay, good. So what did I gain by doing this? I gained okay, I skipped this indexing thing. Okay, indexing is done automatically. Indexing is done automatically in this case. Okay, so this is the format. For loop, this is a completely new syntax with the C++11. For loop, there should be an array here, and you say integer, some variable name, and okay, this type of this data type should be the type of the array element type. Okay. How can you do with two-dimensional arrays? Well, in that case, what's a two-dimensional array? Two-dimensional array is an array of arrays, right? 20 and 10, right? What is each element of this array is another array. So this data type should be an array, so it should be an integer pointer. Okay, integer pointer. You try it yourself. This range-based for loop actually, well, it is okay to use it with the arrays, but usually we use it with the elements of this standard template library. Standard template library, STL. In STL, we have many classes. One of them is a string. Okay. Other than string, we have vectors, we have sets, we have maps, etc. Each one is a different container. They behave like arrays, but they are much more complicated and much more useful than arrays. Okay. So this range-based for loop is going to work on the elements of these kind of containers. Okay. Good. So don't forget about this. We are going to use this a lot. We are going to use this a lot. Okay. Good. By the way, instead of doing this, you could say declaration type of ARR1, right? Remember the declaration type? Our new declaration method in C++11 along with the auto. You remember that? We could use it there. I mean, if you don't know the type of the array elements, that's kind of answer to your two-dimensional arrays, Muhammed Bedir. Okay, so arrays in memory, we already know that because I have already drawn the picture. They are guaranteed to be sequentially allocated, and they follow each other. They follow each other. Here is an example. When you say A6, okay, integer A6, the compiler says that, okay, the array A will start at this address, 1023, okay, and there is enough space to fit 6 integers. And assuming that each integer is 2 bytes in this case, well, it might be different depending on your system. In this case, it is 2 integers, just 2 integers. When I was at your age, integers were 2 bytes, really, actually, it was 2 bytes. And if it is 2 bytes, then the total array is going to be 12 bytes, right? It's going to be 12 bytes, and they are stored sequentially. It will come, one will come after the other one. That's why when I say A plus 3, this will refer to this position. It is guaranteed. Okay? There cannot be any space between A0 and A1. There cannot be any space between A0 and A1. The picture is different for the structs. Remember, structs are our second aggregate data types. With the structs, there might be spaces between 2 elements of a struct. Okay? When you say struct ABC, okay, integer a double b. There might be some space between this integer and double in the struct. You don't have a very good control on the compiler, but there cannot be any space between the array elements. Otherwise, I mean, if there are some space between them, then this calculation wouldn't work. Okay, so I know this now. Okay, good. And the addressing things and everything works exactly the same as before. So how the arrays behave in memory, okay, we already looked at it. You know the initialization. If you say I have an integer children tree, and this is how you initialize it, and we are going to use this a lot, like the integer initialization. Okay, sometimes we do this, we don't like to specify the size, but do the initialization, and you calculate the size yourself, we say to the compiler. Arrays and functions, of course, we can send the complete arrays to the functions and return arrays from the functions. Okay, these can be all done, and the book talks about it. First, the book talks about, can I send a array element to a function? Of course, we already know that. I'm going to skip this. Okay, let's look at entire arrays as arguments, and this is, of course, is possible. Okay, this is a function that takes an array and its size. Okay, we have written such functions in our CSE102 class, and maybe I will show you one or two programs on this, and I will not go into the details of it. But it looks like I am out of time for today, so I will stop at this point, and we will continue tomorrow. Are there any questions? I can take the questions right now. Are there any questions? So regarding arrays, I didn't say anything new. Maybe the range-based for loop is the new stuff. We kind of repeated what you have known so far. Okay, if there are no questions, okay, that's it then. I'll see you tomorrow.
Teacher, can I ask this?
Sure.
Can we use pointer array as a two-dimensional array? And which one is advantage or useful?
Can you use a pointer array as a two-dimensional array, and which one is more useful?
Yes, teacher.
Well, I think on chapter number 10 or something we will talk about it, but both of them, they have their own uses. I mean, if your array is like this two-dimensional 10 and 10, that means that in your memory you have something like this. You have something like a long position like that. There are 100 elements in it. The first 10, the second 10, and it goes, this is the last 10, right? This is the picture if you have a two-dimensional array. But if you have a array of integer pointers, in that case you are going to have array of 10 elements. Okay, this is your 10 elements, and each one is pointing to another array in the memory. Okay, so what would be the advantage of this green stuff over the red stuff? Which one uses more memory, green or red?
Red.
I don't think so. Why do you say it's red? Red just uses 10 times 10, okay, 10 times 10, 100 integer position. This one says that, okay, I have 10 of them, and each one uses 10 integer positions, but also I need some memory for storing these pointers, right? So it's going to need 100 integer positions plus 10 integer pointers, more memory. Okay, so if you are concerned about memory usage, do this. But what is the advantage of this one over that one? Sometimes I like to use this one. What did I say? Each one is a 10 element, right? This one is 10, this one is 10, and there are 10 of them. What if I want this to have 12 elements, and I want this to have 8 elements, and I want this to have 3 elements, right? This is possible with this kind of array, but it's not possible with this kind of array. So I wouldn't say red is better than green, green is worse than red, etc. It depends on your needs, okay? But all you need is like a regular n by n matrix, then this is more useful than that. And there is lots of dynamic allocation, deallocation stuff for this kind of picture. Okay? And we'll talk about this when we come to chapter number 10. Yeah, exactly, Yunus Emre. Good. Okay. I'll see you tomorrow morning.